In this lesson, we're going to play around with graphing, and often we'll have what we call an x-axis horizontal. Sometimes we might give it a different letter. And we'll have a y-axis, which is vertical, and sometimes it might have a different letter. For this section, we'll stick with those letters. In the next section, we're going to look at some different things, like X could be year, so we might label year instead of X, and Y could be trillions of dollars, so we might have that labeled instead of a Y. When we use points in a graph, the first number represents an X value for the point, and the second number represents the Y value for the point. So down here, I can say I have the point -2, -3, so X is -2 and Y is -3. So here you're going to practice plotting points, and sometimes those points will line up. So we'll see some examples of that. Other times they won't line up, and that happens too. So in this example, I have a dot tool I can use on the grid here, and I want to locate each of these points. And again, we always state the point, the horizontal value, then the vertical value. So the point X is 3, Y is 3 would be right here. I have the point 8 for X and 8 for Y. I have the point 7 for X and 8 for Y. So I usually start with the X value and then trace over to the Y value. 5, 4, and 2, 2. And that's all I need to do there. Similar example here. I have some points. All I need to do is plot them. I'll leave that for you. In this case, I have points that are supposed to be a line. Now, the first point they're calling the x-intercept. So let's plot it and think about why we'd call it the x-intercept. So -3 is 0. -3, 0 means don't go up or down. So I'm just going to go right there. And next I want 0, 3. Now notice I'm on the line tool here, and I plotted one point, and now it's wanting me to plot the other point to make the line. So I want to plot the point where X is 0, Y is 3 on my version. So I click once I get to that. So I'm going to do that again. Graph the line that has an x-intercept of -3, 0 and a y-intercept of 0, 3. So I'm on the line tool already. So I'm going to go find the point. I'm just moving my mouse around. And once I click, it sets a point. So there's -3, 0. Now I'm just moving around, and I want to go to the point 0, -3. So I don't click till I get to that point there. Once I make 2 points, it's done. Notice nothing's happening now that I move that around. I'm not going to click again. And that should be all I need for that question. Let's do that again. -2, 0, 0, 2. So we're on the line tool already. -2, 0 would be don't go up or down from there. And then 0, 2 would be here. So that should be the line I want through these 2 points. Now let's see, this is called the x-intercept, -2, 0, because it's a point on the x-axis. It's where the line intersects the x-axis. The other point, 0, 2, is where the line intersects the y-axis, so it's called the y-intercept for the line. Sometimes knowing those points is nice. Here, I've got some work to do first. So I need to plug in the value x equals -2 and then calculate what y should be. So I'm going to go grab a calculator for that. And I'll start off with Desmos Scientific, but there is a Desmos graphing calculator. So my formula was to take 1.5 times some x value and then add 1 to it. Let's double check I got that right. Yours may be a little bit different. And the first x value I want to plug in there is -2. Whenever we plug in negative numbers and fractions, we should always put them in parentheses. So this is telling me that I calculated the y value of -2. So if x is -2, y is also -2. Let's plug in -1 and see what happens. So I could just replace this number. Instead, I'm just going to recalculate 1.5 times, use parentheses because it's a negative number, and then finish the equation. This time it's -0.5. Next, we do that plugging in 0. And now since 0 isn't negative, I could just type a 0. Don't have to have parentheses, but they wouldn't hurt. And then they want me to plug in a 1, so 1.5 times 1 plus 1, and then a 2. So I have y values 1, 2.5, and 4. 1, 2.5, and 4. All right, plot the 5 solutions found above and graph the equation. Okay, what does that mean to graph the equation? Well, that's what we did in the previous example. This is a graph of an equation. Now, we weren't given the equation, we were just given 2 points, but we'll do something similar. So first, I want to plot the 5 points I found. So -2, 2, or -2, -2, excuse me. And -1, -0.5, that one's a little trickier, should be around there-ish. And 0, 1, 1, 2.5, so x is 1, y is in between 2 and 3, 2.5 should be about there. Oh, look, these are lining up nice. And then 2, 4, 2, 4. And once you plot a point, if you point to it, notice my cursor changes shape. So if I need to, I can move it if I didn't put it in quite the right spot. And oh, this is nice. It looks like it's jumping by 1/2 each time I drag it around. That's cool. All right, so I've graphed the 5 points. Now to graph the equation, I just need to draw a line through any 2 of those points. So I'm going to go switch to the line tool, and I'll just pick the first one and the last one, but any 2 should work. Again, I'm getting extra information down here. Select this icon to plot the points, and then select that icon to graph the equation. See if the computer likes my work. It does. Cool. This one here, let's see, a machine your company owns has a value given by V equals -4.8 times T plus 8.8. V is the value in thousands of dollars. T is years after the date of purchase. Use the graph of the equation, graph the equation. Okay, so we could graph this in a couple of different ways. We could try to plot some points in a table like that, or we could use a computer to graph it for us. So I'm going to try a computer. So Desmos has a graphing calculator, so I'd recommend using that. And with Desmos, I have to enter y's and x's. So just a note on this one, oops, excuse me, whiteboard out. So I was given V equals -0. Oops, my pen is being bad, or my hand is 0.48 T, and they had parentheses around that, plus 8.8. Let's make sure I type that right. Negative, okay, that looks good. And most graphing calculators can only use y's and x's. So for a graphing calculator here, I would have to, my pen is being difficult. Oh dear. Can't see what I'm writing. Y equals -0.48 x plus 8.8 is the way I'm going to enter it into the graphing calculator. So I'm going to use an x instead of a t and a y instead of a v. So y equals, instead of the v, equals -0.48, and I don't have to have parentheses here, times x plus 8.8. And nice thing about this is I can click and drag and move it around, and I can zoom out or zoom in. And then I'm asked to estimate here the value after 4 years. So T is the years, so that would be my X. So that's 5. 4 would be over here, and 4 seems to be, looks, that's 5 and that's 10. That looks to be about 7 on my graph. So I think this has the point 4, 7. And I can also plot points on here by just typing parentheses. I think this graph has the point 4, comma 7, close the parentheses. Not exactly, but it's close. All right, so graph the equation, use the graph to find the value of the machine. So let's see, the value of the machine is V, ooh, but it's in thousands. So that's not just a 7 there, it's a 7,000 according to this. So it's important to know what our variables mean. So I think my answer should be 7, 1, 2, 3. Okay, how did I know that? Here's my equation with V and T. I used X's and Y's instead for the calculator. They're telling me V, the answer when I plug something in, is the value of a machine in thousands of dollars, and T is the years from the date of purchase. And I wanted to estimate the value of the machine 4 years later in thousands. So let's see. So the question is, do they want the 7 knowing it's thousands or 7,000? Let's find out. Didn't like that. Okay, so it's assuming I know 7 means 1,000. Now I got it right. All right, that was a tough one. Let's get a similar one to make sure we can do it. Here we have a slightly different equation. So let's go to my board and write it down. So my new equation, V equals negative 0.34 T plus, I think it was 7.5. Yep. All right, and the catch on this one is to put it in a graphing calculator. I'm going to rewrite this as y equals negative 0.34 x plus 7.5. And then I'm going to use the graph to guess the y value when x or t is equal to 2.5 this time. 2.5 years later. Let's give it a try. So I'm just going to turn that one off, turn that off. I'm just going to add a new one. Y equals negative 0.34x plus 7.5. Notice last time I did a times x and this time I didn't do the times. The computer's okay either way. Some computers need you to type the times, some don't. This one takes it either way. All right, 2.5. So 1, 2, 3, 4, 5. 2.5 would be right in the middle here. And it looks like not as easy as the last one. 5, 6, 7, 8, 9, 10. Here I can see the y-intercept is the 0.07.5. So if x is 2.5, it looks a little bigger than 6.5 there. Ooh, Desmos, that's nice. I can point and click on the line. Wow, I love Desmos. Hey, check that out. Desmos says it's about 6.65. Nice, Desmos. All right, if your graphing calculator doesn't do that, then again, you have to guess. So I was thinking it was a little bigger than 6.5, so I might guess 6.6. Okay, and here they're telling me the value is in thousands, so I don't have to actually put the times 1,000. So here I might say 6.6 was the guess I was going to make before Desmos showed me the answer. Cool, good guess. Let's try another. All right, what family of equation is this in? All right, so we're given quadratic, exponential, linear. This is something I hope you've seen before, but if not, more of this is in the lesson. So linear is pretty straightforward. Things line up. So we're asked to plug these x values into that equation. So I think I'll do this in my notebook. So we are going to make a table for x and y. where y is equal to, let's double check that, negative 2x plus 4. Negative 2x plus 4. And we're going to plug in negative 2, negative 1, 0, 1, and 2. So to make the calculation off to the side here, I can write y equals, or you could skip the y and just write equals, oops, negative 2, parentheses, negative 2, plus 4. So negative 2 times negative 2 is positive 4, plus 4 means I should have the point negative 2 eighths. And then we just keep doing that like I did on the calculator earlier. So you can do it on the calculator or you can do it by hand. So we're going to have a negative 2 times negative 1 this time, plus 4. So negative times a negative is a positive. So that's 2 plus 4, 6. If we plug in 0, we'll have negative 2 times 0 plus 4, which is 0 plus 4, or just 4. Negative 2 times positive 1. Don't really need the parentheses anymore, but it's okay. That would be negative 2 plus 4, which is positive 2, and negative 2 times 2 plus 4. So I'm just plugging in the number I'm given over here. So that's going to be a negative 4 plus 4, or 0. All right, so I need the values I have are 8, 6, 4, 2, 0. And oh, they're nice. They're dropping by 2 each time. It's an easy pattern. 8, 6, 4, 2, and 0. And let's see, here we want to graph the equation just by plotting 2 points. So I can pick any 2 of those points if I got them right. Hopefully they all line up. So I'm going to plot the first one, negative 2 eighths. That would be right there. And I'm just going to kind of move over to where the numbers are. We have negative 1, 6, which would be there. And then we have 0, 4. It looks like they're going to line up. 1, 2 is over there. And then 2, 0 is down there. Okay, so I'm going to do the first one and the last one. And notice here that my other points do seem to be there. But I'm not clicking, I'm just pointing. So negative 1, 0, right? Negative 1, 6 is there. And then 0, 4, 1, 2. So I must have done the right calculations because they are lining up. So this is linear because they line up. And later we'll look at equations where they curve, and the 2 curves we're going to look at are exponential and quadratic and exponential. So same thing as before, we're going to plug in each x value in here one at a time, calculate the y's, and then we're going to try and plot them. So this looks kind of like the other equation. It's in y equals some number times x plus some other number. So I'm going to guess it's linear. I'm going to plug in, let's see, 4 times negative 2 is negative 8. Negative 8 minus 4 is negative 12. I really should check this on the calculator. 0 is a nice number to plug in. 0 minus 4 is minus 4. So I'm going to just cheat a little and just plug in those 2 at the line. Negative 2, negative 12. Oh, it's off my screen. I got to try a different one. All right, fine. We'll plug in. Let's try plugging in negative 1. 4 times negative 1 is negative 4. Minus 4. Negative 4 minus 4 would be negative 8. Okay, that is on my screen, so I could do that one. Negative 1, negative 8's way down there. And then 0, negative 4 is right here. All right, so I think that's going to be the line. And I guess we'll double check another one. If we were to plug in 1 here, 1 times 4 is 4, minus 4 is 0. Does this graph seem to have the point 1, 0? It does. We plugged in 2. 2 times 4 is 8. Minus 4 is 4. So I think that should be 4. You should definitely check those numbers on a calculator. Does this graph have the point 2, 4? It does seem to. Notice the instructions, though, say to make the graph by just plotting 2 of the points, any 2, but just use 2 of them. Nice. All right, hope this helped. Keep up the good work. I'll catch you later.